So now we'll use another example of delta H naught of formation to solve a delta H of a reaction. So we have here methane plus 2 O2 gas giving us CO2 gas plus 2 H2O gas. And typically you'll be given a table of these values, which I have listed here for you. So our delta H naught of a reaction is going to equal the sum of N, which is the number of moles, times the delta H naught of formation of the products minus the sum of N times the delta H naught of formation of the reactants. So here, in this case, we can set up our delta H naught of a reaction, and that's going to equal 1 mole times the delta H naught of formation of the CO2 plus 2 moles times the delta H naught of formation of the H2O minus 1 mole times the delta H naught of formation of the CH4 plus 2 moles times the delta H naught of formation of the O2. So here's our overall equation, and given a chart of values, we can just go ahead and plug and chug and calculate the delta H naught for our reaction. So we're going to have 1 mole times negative 393.5 kilojoules per mole for the CO2 plus 2 moles times the delta H naught of formation of the H2O, and remember that this is in the gaseous form, so we have to make sure that we pick the correct value, which will be negative 241.82 kilojoules per mole minus the whole quantity of 1 mole times the delta H of formation of CH4, which is negative 74.8 kilojoules per mole, plus 2 times the delta H of formation of oxygen, which is going to be 0. So if we go through and do the algebra, our delta H naught of reaction is going to be negative 802.34 kilojoules. And anytime you're given a chemical reaction, you can look up these values, which you will find in your appendix of your textbook. And if you have this appendix handy, you can easily calculate these by using the delta H of reaction is equal to the sum of the delta H of formation products minus the sum of the delta H of formation of the reactants.